annuities end early. That's just on the next page. 73, thank you. Right. What do we mean by annuities end early? It's exactly that.
Yes.
It means you are paying each month or each quarter, you're paying something into an account or an annuity fund, and then at some stage you stop paying. But you don't withdraw the money, it stays in the account. Right, it stays in the account. But then what happens from here is that the money that's been saved up to here will just grow in a compound interest way up to the end of term that you decide. Okay, that's all. So it's actually just a combination between your annuity formula and your normal compound interest one. Okay. So what's applicable over here is this one over here is x. 1 plus I to the power of n minus 1 over I. Okay. That's applicable up to that point. And now you need just to determine what will the interest be up to the end of the term over there. And all you do is you multiply with what is left over. Okay. And you get the answer for that. As easy as that. Okay. Nothing spectacular. We will do two examples on this. One is very easy, straightforward. The other one has got more flesh to the bone. But it's very easy actually. Let's continue with the work example on page 73 then. Okay. Straightforward. All that we need to focus on is the amount of payments or the term. That can be that's the only challenge that we have actually with this. It says Selvent pays a monthly amount of 1,500 into an account. So we do know X is 1,500. Interest rate is 9%. It's working. Okay, great. The interest rate is 9%, 0.09 compounded monthly. Okay. 30 years. Okay, 30 years. Okay, we need to multiply by 12 if need be. Okay. He stops his monthly payments but leaves the money in the account for a further 2 years. Okay. So he's done his payment over here. He stops there, and then for another 2 years, he leaves the money in the account. Calculates how much he had in the account at the end of 32 years. Good. So all that we need to do is this. X is 1,500 times 1 plus 0.09 over 12 to the power of, it's 30 years, right? So it's 30 times 12 minus 1 then over 0.09 over 12. Okay. And then for the additional 2 years, we just multiply with the bracket. It will be 1 plus 0.09 over 12 for 2 years, but remember, it is compounded monthly. Okay. Right. There's no variables on that side or unknown values, so we can just feed that information to your calculator. Try to see if you get to the right answer. The 3285,489,41. Okay, sorry. Let's complete our little worksheet that I hand out to you. That's in your book somewhere. And it's also somewhere here with me. If I can find it, that will be great. Right, the savings one, the savings and growth one. Okay, this one over here. Not the loan one, but it's the savings one. Right, the one that we're gonna, sorry, the one that we're gonna look at is the one number 7, the block number 7. Block number 7, just complete in there, annuities end early, as we had here. Annuities end early. That is the route from there.
So on the growth savings.
On the growth and savings, yeah. On the growth and savings. Annuities end early. Number 7. And then number 3, calculate value until paying stops. Calculate value until paying stops. Calculate value until paying stops. That's number 7. Number 3, sorry. Okay, the top one, number 1, just write the normal annuity formula. Meaning this one over here, that one. Only that one. Writing that. F equals to this one over here. Not the round bracket, only the square bracket. Yeah, number 1. Yes. Number 3. Number 3, calculate value until paying stops. And then number 4, lump sum grow with compound interest. Lump sum grow with compound interest. Yeah. And then number 5, block number 5, right in there, A equals to P bracket 1 plus I to the power of n, meaning this one over here. Okay, your compound interest formula. Okay. Let's do another example. Well, actually, let's do on page 75, number 3. Let's have a look on page 75, number 3. Right, let's make sense from that English. Tondo saves for a new scooter by depositing quarterly payments, okay, by depositing quarterly payments into an account that pays an interest rate of 12% per annum compounded quarterly. Okay, thank you. So he's paying quarterly payments and the interest also quarterly. Everything is fine there. If he plans to save 50,000 in 4 years' time, okay, calculate the amount. Yeah, number 3. Calculate the amount that he must deposit each quarter. That's nice. They could have asked each month, then it will be more complicated. But each quarter, if he starts his first payment in 3 months' time, 3 months is a quarter. So that is normal. Okay? That is normal. In 3 months' time, and makes his last payment 3 months before purchasing the new scooter. Okay. So what happens here is he's doing quarterly payments at a certain time, and for the last quarter, this last quarter over here, he didn't make any payment, but his money just stay in the account and draw interest for that last quarter. Okay, so that's all that happens over here. So the question is now, how much must he save? Why did he end in the payments in before the time for one quarter? Don't know. Perhaps you just want to save some petrol for the scooter. What will it help if you've got a scooter but you cannot drive from the dealer to your house? Okay, so whatever. Okay. So let's see how we're going to deal with that. So remember, this part over here is the normal annuity formula that we're going to use, and this one over here is the normal compound interest that we're going to use there. Just make sure that we got our number of payments correct. That is the trick. So let's write down. So X is what we need to determine these monthly payments. The interest rate, I think it's 12%, if I'm not mistaken. Quarterly. Okay. It's 4 years, right? Yes. It's 4 years. 4 years. Okay. But okay, how many payments actually can he make in 4 years' time? Times 4. Okay. So actually, if he contributes into the account each quarter, it will be 16. Okay. But he didn't make a payment the last quarter. So how many payments did he make? Only 15. Okay. He made only 15 payments. Okay. So let's calculate that. We have X, what we need to determine. 1 plus 0.12 over 4 to the power of 15. Okay, 15 payments. Minus 1 divided by 0.12 over 4. My bracket that I need to multiply with, the compound one, is 1 plus 0.12 over 4, only 1 quarter. Okay, only 1 payment that he missed. Equal to, what is the end value? 15. I think it's 15. 50. Okay. And this value over here, this bracket, doesn't have any variables, so we can calculate this, we can calculate that one, multiply these two with each other, and divide it into 50,000. Then we will have our answer. Do you want to try? Yes. Okay, try. Right, so answer 2610,03. Here we go. Okay. This stuff is easy. So only trick was to play around now with the amount of payments. Okay. The possible payments that he had, that was possible for this time, was 16. 4 times 4. It was 16. So 15 plus that 1 gives me 16. Okay, good. Page 74, number 1 and 2, please. All right, thank you guys, and then see you then on Monday. And that's it.